Okay, good morning, good afternoon, everyone. My name is Chad Kwewan Coven. I am a product marketing technical specialist here at Dataiku, and I am ecstatic to join y'all today for a very fun webinar. We're going to hop into really the inner workings of the Dataiku LLM Mesh architecture, and it's going to be a whole lot of fun. So before we get started, I always love some crowd participation. I would love to hear where everyone is watching from, everyone is listening to our voices from. Go ahead and leave that in the chat. Just say hi, say where you're calling from. I see New York, Canada, Miami, Florida, Texas, Singapore. We have people from all over the world, so we're very excited that you are here joining us. And you could have spent your morning or your afternoon or your evening anywhere, but you decide to spend it with us. So we thank you for that. So before we get into things, just some quick housekeeping rules. Currently, I see many of you leaving where you're from in the chat. That's awesome. If you do have any questions that are specific to this session, go ahead and pop over to the Q&A tab on your screen, and you can leave any questions there that we will answer most likely at the end of the session. But a couple questions we may respond to during the session within the chat. Also, for all of our friends over on LinkedIn, hello. You can also leave your questions in the chat and we will get to those as well, most likely at the end of the session. We'll leave about 10 minutes at the end of this session to go over those questions. Now, without further ado, as I said, my name is Chad and I'm joined by the immaculate, incomparable Nate Kim, who is one of the field engineers here at Dataiku. So Nate, I'll go ahead and allow you to introduce yourself.
Yeah. Thanks for that, Chad. Good morning, good afternoon, good evening, everyone out there. I'd like to thank everyone's attention and taking your time to join. My name is Nate Kim. I'm one of the senior field engineer at Dataiku, helping customers with architecting, deployment of Dataiku, and also help customers drive best practices on LLM Mesh, generative AI from an infrastructure perspective. The title of the webinar today is called Dataiku LLM Mesh Architecture, where I'll go over some common challenges we see across, as well as some deeper dive of underlying architecture. LLM can be viewed from a multiple angle, but for today's context, our target audience is solutions architect, MLEs, maybe an existing Dataiku admin who are looking to unblock LLM Mesh capabilities for the end users. Chad, am I free to kick us off?
Yep, I think we're ready to go.
Awesome, let's kick it off. Now, before diving into the actual architecture, let's take a few moments to talk about what LLM is. So I took some time to ask ChatGPT what the definition of LLM is, and here's what it said. LLM stands for Large Language Model, which refers to a type of artificial intelligence designed to understand and generate human-like text based on extensive training data. I think the key word here would be extensive training data, where it can comprehend human-like behavior, such as summarizing text, providing answers and responses better than before. So if you think about it, LLMs are really excelling at specific tasks. So that's generating a coherent and credible continuation of input text, otherwise known as prompts. And they were also trained with extensive amount of textual data, encompassing diverse sources like books, articles, websites. And through this training process, it required a remarkable reasoning capabilities, which make them much more than just a writing assistant. And particularly, they're really effective for wide ranges of natural language tasks. And so many organizations are wanting to take the advantage of this opportunity and find creative ways to solve problems. But there are also things to think about. And so what is there to think about? And here's some examples of challenges, questions that an organization would need to start thinking about. And these are not exclusive lists, and you may also uncover as you start venturing into it. But as a starting point, we've identified these 5 pillars as a foundation. And it's important to understand that everyone plays a key role, bringing expertise and cooperations across these pillars. So let's dive into these pillars. Compute and infrastructure. Some of the questions that you might ask is, how do you properly enable usages for the users? What are the compute requirements? How can I scale out the workload with the growing number of users, maybe usages? Enterprises is thinking about balancing the user enablement while also trying to find and provide the right infrastructure with an appropriate cost control. Privacy, security, and compliance. How do you enforce governance? How can you control users from spilling confidential information? Are the sources reliable? What about personally identified information? Security becomes an important factor as you start adopting into this generative models internally or externally. And organizations are tied with creating a governance and control for it. Choice and dependencies. There are new models and new providers coming out on a daily basis. How do you ensure that what works best can be used? Can I use a different model? Can I use a new provider? How can I get access to new models? And LLM and generative AI is a growing field that will constantly evolve. Organizations are tied with finding out what the right models, tools to use without sacrificing your existing tech stack. Ethic and trust. What are some trainings out there that can help to drive the best practices on the queries and responses? How do you ensure the users are adopting into responsible AI? IT is often tasked with providing guardrails and materials to better educate the end users as well. And then last but not least, model accuracy. Are the responses accurate, or are they generating hallucinations? How can I improve the models and how it's being used? How do you monitor and ensure that the models used are working at an optimal, maybe acceptable level? How do you tie all this back into the LLM ops? And these are challenges that everyone as a stakeholder in the organizations have to coherently think about. Everyone has a part from providing the right infrastructure to the right people to unblock the usage, but at the same time have a safeguard. And this is an ongoing effort and something that you have to think about constantly. In the context of our presentations and webinar, it's going to be more focused on the 3 points, the 3 first points, as we like to take a different angle from providing emphasis for the enterprise IT that works to unblock usages for the end users. And this is where LLM Mesh comes into play. LLM Mesh can help with challenges we're facing, not only from a user level, but also from an IT perspective, looking to provide the right infrastructure and guidance to complement the business challenges. LLM is a centralized feature to unlock enterprise-grade and secure access and building generative application, models, and services all on Dataiku. It still keeps the same Dataiku feature by allowing no code to full code on the platform, but also handles routing, orchestration, as well as administration for it. And the benefit of LLM Mesh include, 1, decoupling the application by freely choosing different LLM providers during the design phase to decide on the best application built for the service layer. 2, enforcing a secure gateway, basically allowing the IT to properly audit and manage control access to LLM providers. 3, ensure safe use, helps to evaluate sensitive information such as PII. Cost control helps to aggregate the cost of usage, track down spending based on the tokens, and also help caching the queries and responses to improve cost and performance. And 5, enrich queries and responses. So standard application development components like capabilities used across multiple applications, things like retrieval, augmented generation, So RAG is becoming more of a standard way to infuse the internal company knowledge into the responses of an LLM. And basically, RAG works by indexing your internal knowledge you built by vectorizing series of texts or documentations before the query is generated and injected to enhance the responses that are generated. And the LLM Mesh provides integration with vector stores and implements a whole RAG pattern with no code intended. And we have all integrated, so we've integrated all of the GenAI capabilities in a single product where customers already have their analytics and ML flows. And we also provided pre-built components for both clickers and coders and consumers of the GenAI. I think another differentiator that we provide is multi-persona, right? Allows individuals or teams representing a different phase in the cycle to better coordinate, such as MLEs or IT personas looking to optimize the end users from a platform perspective. And it can build better coordinations and collaborations to help optimization in terms of usage. We also offer customers the freedom to choose between all LLM providers and then ability to do without rebuilding the workflow. And because our LLM Mesh decoupled the application or business layer from the underlying models and AI services, you can future-proof your application and reduce technical debt and dependencies. It allows you to freely swap out providers and models with the better one, better ones that are emerging without actually changing your entire workflow in the front end. Now that we've uncovered the idea of what LLM Mesh does, let's actually take an angle of from an IT and then dive into it further. So I mentioned that we have 3 topics as a focus area, and I've broken down into basically what do IT people care about. And I think the foremost is compute and infrastructure is the most commonly discussed topic. And with the rapid development of and iterations, ITs are basically tasked with providing the right infrastructure and pieces together for end users to use for generative AI and LLM purposes. And this can range from creating the right platform, right clusters, different types of GPU, model sizing, data sizing without actually breaking the bank. And this task often involves a requirement driven by the business use case decisions to optimize the right infrastructure for the best practices. With the cloud services providers emerging, organizations now have the ability to shift from CapEx or capacity-based expense to OpEx or operationalized expenses, which basically means that you have flexibility to choose a compute usage driven by the requirement rather than procuring it up front. Now, in the context of LLM and generative AI application workloads, there are 3 major usages across the industry. One, which is not very common, is pre-training or actually building your base or foundation models. So pre-training is a very, very, very rare occurrences as it'll take a lot of parameters and a lot of training hours. So for example, a GPT model used for that I had pulled up earlier is trained over 100 billions of parameters and making the models really, really, really big. And these models built or served as the foundation models, generally through an LLM providers or hosted LLM provider to directly to provide responses. Number 2 is fine-tuning. And fine-tuning basically means you're taking the base model and then you're further training to adapt models to excel in specific tests. So this would be a similar case where you're providing your data set and then tuning the models to excel in specific tasks that you want the models to generate. And then the third, which is the most common and how Dataiku would typically interact with it, is the inference. And this could be the case of where you are using a hosted LLM provider or hosting your own LLM models, which is also a common pattern that we see across the industry. So basically what it means is you're choosing the set of LLM models that you want to host externally or internally, and selecting how that model is going to be exposed for consumption. So this model inference is actually receiving the query inputs and then generating responses for consumption. And Dataiku can work with all these variations and usage to meet the business needs and use cases. So let's look at some usages and features. So here are typical usages of LLM feature with Dataiku. This breaks down how an organization is considering LLM usage. With level 1, you integrate LLMs with pre-built component. And this means LLM providers. It could also mean you're internally hosted. But typically, organizations starting to explore LLMs start with a pre-built component. I want to say generally 70% of Dataiku customers start here. And this pre-built in Dataiku means native recipes, which are noted as a pink icon in the screen, interacting with pre-trained models and inferences provided by the LLM providers. Level 2 is prompt engineering, which is a technique where you're putting different efforts and optimization on the prompt itself that you're passing to get the best results. Basically, things that you pass into the LLM when you interact with it to generate the best output as a response. And this is where responsible AI also comes into play. Although this would be out of the scope for the presentation, many organizations are also adopting and looking to improve prompt engineering as a mechanisms to improve on the overall model response. Number 3 is knowledge and RAGs. I talked about RAG earlier, which is also getting popular. It basically enhances the query sent with an internal documentation and a form of vectors to weigh in on your responses to most up-to-date or relevant context. And this is getting more popular as organizations are finding ways to provide proprietary documentations or information to enhance the queries and responses. Level 4 is still a bit rare, but fine-tuning the models to set the right context or settings for specific context handlings, or even building your own pre-trained model is also another way that Dataiku could be used as a feature set. And you see that pink icon is fine-tuned recipe. And Dataiku does, again, provide the native recipes to handle those more easily. And LLM Mesh can help with all these 4 levels of emerging scenarios. And let's dive into the components on how it actually enables those 2 features. The LLM Mesh can act as a gateway for your GenAI application built. Every interaction will use the same API feature to interact with your application. And you can see the LLM Mesh API is decoupled into a business layer or an application layer with lightweight APIs that can scale out for query filtering, response filtering, routing, and auditing. And the actual heavy lifting is pushed out to the services provider, in this case, service A and service B, where service A and B represents different LLM host provider or the custom one you built locally. So when a query is submitted from the left side, it'll be using the LLM Mesh APIs to do the following. Query filtering, assuming the connection that you use for the LLM provider has it set up, and it routes the request for generations. It receives the input, and then API will also provide response filtering on Dataiku from the generated responses for things like forbidden terms or toxicity detections or PII detection prior to providing the responses back to the users. And these API calls are audited within Dataiku platform and compiled, which you also have the flexibility to choose either a metadata piece or actual full query and responses as an admin. And this allows you to further break down the audit trails to then build out either a data set for the fine-tuning purposes or even just auditing purposes, all in Dataiku. API, which is serving the business application, as a lightweight, and its purpose is to solely collect the responses, calls, and send the queries over to the hosted LLM provider and receive response. And if you have a RAG pipeline built in between, it'll simply call the vector database vector store before the queries are sent over to the providers. So diving into the routing piece, calls are performed in a FIFO, or first in, first out action, where an API could be making a request to multiple services in parallel. And this is defined by creating a connection on Dataiku and giving users ability to select configurations to run on their project. LLM Mesh will compile and send queries down to the third-party LLM services or your private LLM or self-deployed LLM that you can host it on local or Kubernetes as a Hugging Face connection. And this is an alternative method to internally call your privately hosted models or even fine-tuned models that you wish to use. And regardless of which provider to use, Dataiku will use the same LLM Mesh API to interact and create easy portability, keeping the same dialect. And through LLM Mesh, you can manage your local models and use Elastic AI to provide inference services on the customized or locally hosted model. And this will natively tie in with Dataiku feature to create easy model inference within your organization to downstream applications without having to expose the queries and responses. The cluster is powered by Elastic AI, which is running Kubernetes clusters under the hood, which also allows the Dataiku admin to then add flexibility features such as adding a node group, instance type, configuring ingresses and egresses, number of clusters, number of nodes, and many more. And this helps to horizontally scale out your inference LLM models hosted. The benefit of doing it here is that business use case and queries and responses that are generated are fully hosted within your premise, basically giving you a private access without exposing it publicly. And when we talk about this, it is important to note that you can scale out to multiple models within the cluster or even multiple clusters to scale out your workload. Multiple models, multiple nodes, and multiple clusters to scale out the workload. And while it's not a magic sequence, most important factor here is knowing the business use case, what is the type of workflow you're looking for, how many active concurrent users, what type of models you wish to use. Is it, for example, is it a 7 billion parameter versus 40 billion parameters? And this will all contribute to overall compute usage. And finding these relevant fields up front to drive down what type of GPU nodes and how many to be selected will be a good starting point. So for example, let's take an example here. A general rule of thumb for hosting a model, and just the model, is calculated by number of parameters multiplied by the model precisions. So generally, models are trained on half precisions or 16 bits, which equal 2 bytes. So if you're taking a 7 billion parameter model, you would simply do 7 times 2, roughly 14 gigs just for the model itself. And so with larger models, this actually may not fit in the GPU node, but Dataiku, with the auto-scaling setup on the Elastic AI, it can be configured to automatically scale out to node groups with additional GPU and also scale out your inference using things like tensor parallelism, which basically means taking a smaller subset of model layers and blocks across different GPUs to let it calculate independently. So what model you'd like to inference becomes an important factor if you're thinking about hosting a local model. You can also call LLM Mesh API from an external application or code running outside of Dataiku as an API call. And so it still maintains the same consistency on the usage. And the code that use LLM Mesh API will basically provide the same capabilities such as query filtering that you may have set up for your organization, routing to different LLM services, and also audit the usage and track where you can build out an additional monitoring workflow, right? So regardless of where the calls are being made, you can still use the same level of API provided as an LLM Mesh. Here's an example of requests that LLM Mesh API interacts with Prompt Studio, which is a full-featured development environment on Dataiku to test and build better prompt for the models, and also gives you the ability to compare various LLM provider model responses. So this is where end users would be testing out their prompt and also using prompt engineering technique to then optimize your responses that are being generated across different LLM providers and comparing the results and find out what works best for you. Prompt recipes for a large batch job for generating text for multiple records, right? This will be a recipe approach where this is where the bread and butter of Dataiku is excelling at. NLP recipes such as summarizations, embeddings for knowledge bank to build RAG pipeline. And then Answers plugin, which is a scalable web application that uses LLM and RAG pipelines to create a chatbot experience out of the box. So this is something that Dataiku has built internally to allow organizations to get started on the chatbot experience with the LLM provider that you wish to use, and also enhanced with a RAG pipeline. So if you're interested, please do reach out to your reps to get this started. Code running on Dataiku via Python can also utilize LLM Mesh APIs to then interact with the service layer. So this would be a code-based approach. But the idea is that giving flexibility and different options for personas to interact, leveraging Dataiku. In the backend, it again streamlines through the LLM Mesh API, thus by giving common languages to work with the service layers, as I mentioned earlier. When the model and prompt recipes and knowledge bank is all built within Dataiku in the design node, the same project can be used and created as a bundle to basically hold metadata. And this deployment methodology has been a very integral part of Dataiku. Bundles that are created will contain knowledge bank and even fine-tuned model if the models are actually locally stored. Otherwise, all the metadata that's used to build a workflow within the design instance can be pushed to a deployer node, which are noted in the center as a project. And from deployer node, you can set up an infrastructure on the automation node or automation nodes to configure and administer project deployment for a batch job. And this project can be used to serve batch-related jobs. It can also then be used to evaluate your LLM models and score for retraining, or even serve web application as a production workload. The important thing here is this hasn't changed. This is how Dataiku did work, is working, and will work. And LLM Mesh, in terms of deployment, works the same exact way as how you would use Dataiku. LLM models and project built on Dataiku, as I mentioned, can then be used by external applications or users via the same API provided, whether it's REST or Python. Excuse me. LLM Mesh API on each node will basically coordinate the calls, the routing, the query filtering, the components that I showed earlier. And so following the illustrative example, users accessing web apps or external application making an API request over the internet would basically use LLM Mesh API to interact, to either inference the models or go through the RAG pipeline, doing the vector search, indexing, and getting responses generated. And this is coordinated automatically, as you saw in those previous slides. One additional thing to note here is this is an example. You can very well confine your users and external applications within your premise as well. So instead of going through the public internet, should your network infrastructure allows it, these calls being made to the nodes themselves can also be privately accessed. I mentioned that Dataiku can decouple into different layers. So with service layer, which is on the left side, will basically hold the API, heavy compute, heavy loads, which can be scaled out across either third-party services. And as I mentioned, for locally hosted models on the right side, clients have the flexibility to control the number of GPU nodes, the sizing, all through Elastic AI offering, which again allows you to create multiple clusters with multiple GPU nodes and inference points that scale out to based on the workload. So in this example, you have two different models stored or scaled out and in respective GPU nodes, but you could very well much fit two models in a GPU or scale out model one to multiple GPU nodes and such. And on top of this, Dataiku can also support with caching to reduce the following: network latency and rates. So these are two components that can be configured to cache the model cache and then query / response. So with model cache, models are generally downloaded and locally stored. This is in the context of locally hosted models and not LLM provider. But what it does is it can download a model locally to the disk so that it reduces the latency by allowing the instance to use models that are directly hosted on disk, or also the Elastic AI or Kubernetes to copy the cache onto the persistent volume that's created. And this can help reduce the latency of fetching the models, that you do not need to fetch the models every single time. Again, this is in the context of locally hosted models. Some things to consider is if your Kubernetes or your Elastic AI does have an internet access, in cases it might be faster to download models directly from the Hugging Face hub as well. And then the second thing to be mindful of here is, if you're a Dataiku admin, is you have to size the volumes appropriately, as the models downloaded are generally pretty big, right? You're downloading the actual model set and storing in disk, either locally on Dataiku instances or on Kubernetes cluster. So being able to appropriately size your volumes is an important factor here. Query cache allows you to store frequently asked queries on disk to reduce the amount of API calls that are being made. Caches are by default stored for 24 hours. And this helps with increased rate as the relevant responses are already generated. So instead of when queries are asked, instead of recompiling the query and then sending it to the LLM provider locally or externally hosted, it'll simply cache the responses that have already generated and then provide the same results back to the end user. So this also saves a lot of cost, because otherwise you would be sending the queries just to get the same responses that the user was looking for. All right. Next, let's talk briefly about privacy, security, and compliance on Dataiku. So granting a sufficient amount of resources and compute solves huge problems, but IT is often tasked to provide it to the end users following the guardrails and safe measures in place. And so we have to think about different consequences it can bring, such as How's the data handled? Will there be sensitive data flowing around? Anyone have underlying access to the models and maybe projects? One thing we haven't really talked about is network security, such as implementing firewall. Those are still intact, right? Still play an integral role as the fundamentals of how users would act or access the platform does not change. But I think in the context of LLM, here are a few things that we can break it down. One is data security, making sure that the data being used cannot be exposed to the LLM providers, and putting measures in place to create things like forbidden terms. And two, access control, preventing the access to individuals or application where it doesn't belong. And then I mentioned this briefly, but network securities following the organization policy and organization network topology also is very important. Within the connections parameter, as you start building out a access for your end users to use and interact with LLM provider, one way to prevent data leakage would be to set up a standardized template for preventions at a global level. And so what this means is the connections, chances are you have a security guardrails that you want to establish. So taking that into a templatized approach and applying that to every connections created before it's actually released to the end users for usage. And also with permissions perspective, you can control access to different AI services and also restrict data access. And this could be all done within the platform. When you set up a connection, you can set up things like PII detection, such as phone numbers, credit card informations, do things like toxicity detections for using inappropriate language or foul languages, even do things like prompt injection on the queries to modify if there's anything that's being injected after the query has been responded prior to sending it over to the end users. And depending on the usage, you can also reject the query or replace it with other words and many more, right? So you have a flexibility to be able to configure this to the very, very granular level that the organization might be requiring it. Not to mention a similar thing could be set up for the responses, all within the same connections. So when a query is then generated and provided, you can pass an additional subset of filtering or replacement so that end users are maybe not provided with inappropriate responses. So let's take a look at an example of what that means. Again, this is a hypothetical example. Here, we have user 1 assigned to group user. And then in the middle, you have 3 LLM connections with connection 1 assigned to group user, connection 2 is to group elevated, and connection 3 is open to all users. And connection 1 has a PII detection configured to reject the query upon detection. The connection is set to be used in the respective projects. So project 1, 2, and 3, which also has a permission set on its own within the project. So just by looking at this picture and the setting, user 1 will have access to connection 1 as it's part of the same group, but no connection 2 as it's not part of the same group, as connection 2 is assigned to the elevated group. And user 1 has permission to use connection 3 as well. User 1 has access to the project 1 and project 2, but cannot use connection 2 and the project 2. And user has access to connection 3, but cannot access project 3 as it's assigned to the elevated group. So that's the background setting here. When a user 1 makes a query is a phone number XXX correct for user number 3 in project 1 with connection 1, but the query is rejected because it detected PII to find out that there's a phone number being requested here. So all in all, this user 1 can use any of these connections at any of these given projects to get a response. Take the same example, but user 1 asks a different question that doesn't have any relevant PII information. So when asking what is the tallest mountain in the world, user received a response, tallest mountain in the world is Mount Everest. So you can see how access control within Dataiku can provide multiple layers of defense mechanisms on the access control to prevent data leakage or data privacy. And also assigning the rightful permissions to only that require it. And this is one example, but the configuration can be done to meet further granularity requirements. So all this to say, you can enforce the same level of defense and mechanisms, all from an identity perspective, as well as on the resource perspective. So connection being the resource, project being the resource, and then independently configure it to truly lock down the access control for the users. Third, IT might also be considering providing a variety of choices and dependencies. So there are a lot of providers, fine-tuned and pre-trained models coming out that might have specific purposes to serve your business needs. And different teams have different requirements, and ensuring that users have the flexibility to use it freely while still providing some level of guidance and monitoring. It can help unlock the true potential of LLM journey. So I think providing the key agnostic feature for end users and easy portability can help the organization solve business problems at a more rapid pace, assuming the privacy, security, and compliances are in place. Okay, taking some time to load. So with Dataiku in the context of LLM, there are a lot of native services and plethora of services provider that work out of box. And this allows you as an administrator take care of different personas that might require different services across the platform. So in the adaptive infrastructure section, we have integration to LLM providers like Bedrock, OpenAI, and many more that can be configured and distributed to the end users requiring it. And we're continuously adding more services, native services onto it. And this helps to develop and test different LLM responses and behaviors, again, without changing the underlying code. And computes for project relevant jobs can then be offloaded to different data sources, for example, allowing users to perform data preparations and exploratory data analysis right on the platform without having to changing underlying integrations or code. And this allows to streamline different data components across various sources such as Databricks, Snowflakes, and computes powered by NVIDIA GPU technology for inference if you're locally hosting your models. And Dataiku recently added a native connections to Azure AI Search Service that are pretty recent that allows to offload vector databases running on Azure for index searching. So this would be for building a RAG pipeline. And these variety of services integration gives user ability to choose what works for them and also allow admins to easily provision or enable end users to meet their requirement without changing any underlying code. So anything in front end. And this unlocks flexibility as well as easier control mechanisms and also remove dependencies on the proprietary solutions. So putting it all together, all these building blocks become components to make up LLM Mesh and provide end-to-end cycle. So let's walk through this architecture. Starting on the left, you have public LLM provider services that gives plethora of list and provider as a native connections. Dataiku has an integration with publicly hosted vector store as I as well, allowing you to create and indexes for knowledge bank. I mentioned that Azure search is also on the list. And in the center is the actual LLM Mesh component. So number one is your design node, becoming the central hub for containing metadata relevant to configure the LLM Mesh gateway. Two, LLM gateway controlling the state of art, providing cost and safeguard to the LLM applications itself. And then three, LLM connections that can be created, taking the gateway configurations. Number four, vector DBs that could be also stored locally for LLM Mesh usage. Number five, local cluster for allowing to either train or infer locally hosted models. And then on the right side, for serving the model, deployer node, as I mentioned earlier, allows to take from a design node and push it into the production, whether it's in the form of batch processing or real-time serving. And this fundamental feature of Dataiku does not change, but admins and IT can now better understand the process of enabling production-level LLM services. Note that there's a two automation node serving inferences, whether it's a RAG pipeline or even just a simple chat completion over a project on a web application or API. And this can also be funded with things like load balancers to route traffics depending on the needs. And so recapping our messaging here, Dataiku LLM Mesh is a common backbone and is centralized feature to unlock enterprise-grade and secure access in building generative AI / LLM applications, models, and services all on Dataiku. And last but not least, example of API documentation and usage examples of LLM Mesh are all on our public documentation. And you can see, just to kind of walk through it, in the center, the native Python client used to call LLM_ID that's created and configured. So admins would already be creating those with the guardrails that have in place. And then users using it to run a query completion, write a haiku on GPT models that will execute and then print the responses. And you can see how simple it's to get started and used with few lines of code from a code-based perspective. Again, this allows API-level approach when interacting internally or external with LLM Mesh, that it uses the same API under the hood. So my call to action for you would be to try out LLM Mesh API. And so I have a few links that can help to accelerate your LLM Mesh learning journey. I also have links for the prospects and clients who might not be as familiar and want to try out and understand Dataiku overall. You can get in touch with the rep or to start on the POC and get on hands-on experience with our product. But we're here. Please do feel free to reach out and feel free to get in touch with your rep to get things started. And with that, thanks so much for attending. I really hope that you had an opportunity to understand what our LLM Mesh hindsight and under the hood brings and into a deeper insight. And I will now turn it over to Chad for closing remarks.
Yeah, so we have a whole bunch of questions. We'll get to those in just a second. As a call of action before we get into the questions, I just wanted to highlight that, Nate, you can go ahead and stop sharing your screen and I can actually share super quickly. I just wanted to share that we kind of went into just a little bit. Actually, Nate, if you want to go over to the next slide. And then just kind of click through a little bit. So we did talk about the LLM Mesh architecture. On top of that, we did just kind of scratch the surface of the LLM Mesh. There's also LLM Mesh Guard services. So being a whole part of the idea of the LLM Mesh and safety and security, and being able to make it available to the entire enterprise with those guardrails. So if you want to know more, definitely visit our website, dataiku.com. So now we can go ahead and hop into some of these questions. There are many of them, so we'll try to hit on each of them. Adam had a question: what tools are most helpful for managing the Kubernetes clusters, hosting inference services from the standpoint of performance and security?
Can you repeat that question again?
Yeah, so he asked, what tools are most helpful for managing the Kubernetes clusters, hosting inference services from the standpoint of performance and security?
From a performance perspective, I think it's something that you have to, it's not a magic bullet in my opinion, unfortunately. Elastic AI created through Dataiku give you the template to create those, pre-configure those respectively. Under the hood, for specifically in specificity of LLM context, we actually provide built-in LLM inference capability through a code environment. And that's packaging up things like VLLM for inference, which you can use to run a native recipes without actually having to configure it, assuming you have a GPU associated with it. From a controlling configurations perspective, you can, for the Elastic AI piece, you can use containerized executions to define how many GPUs you want the workloads to accept, how many loads of parallel tasks or API calls that could be made, all directly on the connections and configurations without actually modifying a single thing on the cluster itself. As far as the cluster security goes, this could also be configured where you can control the access to the Kubernetes cluster itself. If you have a non-created or non-managed cluster outside, unfortunately, this will have to be done configured outside. But the same principle of RBAC strategies can be enforced without having to modify things, modifying things with a lot of depth.
Awesome. So the next question that we have is from Alistair. He says, once a model is built with the LLM Mesh, will it always use the same background API calls until rebuilt? I can actually take this one. So I did respond, Alistair, if you want to read my response, but for short, for the audience, essentially how the LLM Mesh works is once you establish a connection within Dataiku, it's now a persistent connection to that API where you have the ability to use any models that are available through that API. So for instance, if we're using OpenAI or maybe Azure OpenAI, and we create a connection through Dataiku, we begin to use, let's say, GPT 4.0, or we want to roll it back to GPT 3.5 Turbo. We have all of those models available, and we can mix and match any of those models that are available through that given API, or to any other models that we have available through any other connections that we've established through our Dataiku instance. And we can do that at any point in the pipeline, right? We can mix and match at any point. So that is the short answer for your question. The next one that we have is, if we want some of our models to be locally hosted, what is the baseline to compute how much GPU we need? And before we answer that, Nate, I'll actually give you the follow-up also, which is, what is cheaper, locally hosting with GPUs or sending to a third-party service?
Ooh. For the, let's start with the models to be locally hosted. What is the baseline to compute how much GPU will we need? There's no magic bullet answer, unfortunately, because it is still a bit driven by the business use case. I gave an idea of an example of model sizes, right? So from a general rule of thumb perspective, what model you use determine the size of, so basically what type of models you use would determine the size of the model and whether or not that could be fit into the GPU VRAM. Plus, you might want to have a little bit of not storage. You might want to have a little bit of free memory space within the GPU to create things like inferencing perspective. So without going really into the depth here, so the first thing would be the size of the model, right? So I gave an example of the calculation where 7 billion parameters tested, trained with half precision adds up to 14 gigs just to host the models on the GPU. So depending on that, you can compare the GPU nodes and how much VRAM that it might contain. Plus, things like for inferencing, you have to then start thinking about, are there going to be, what are the trade-offs, right? Are the users expecting the responses to be generated instantaneously, or is there a leeway time that you can give in terms of latency? How about inputs that are being generated, right? Is there is it possible to wait a bit until the first token is generated? So typically there's a full set of calculations, but you also want to save some memories, pad in some extra memories for things like KV caching, where all the inputs that are being generated with the tokens that are being generated and the indexes instead of calculating each input sequences independently, some of those get stored as a cache that doesn't have to recompute every single time. That takes up some memory. So there's a lot of components that you have to think about. I think the very starting notion point is to understand what the users are wanting to use in terms of models in the context of what you want to host locally. And then find out what the model sizing is going to be, and then start thinking about, how do I fit this model into the GPU nodes, and then kind of go from there. The second question to that is, what is cheaper, locally host GPUs or send to third-party services? So I think the pricing point is a little bit different here, because typically third-party services are getting charged at a token, right? So per token. Whereas if you are locally hosting it, maybe you don't need a charge for tokens that are being generated, or maybe you might have a chargeback idea that you're creating, or you're billing it back to the client. But there's also infrastructure cost that you have to think about, plus management of that infrastructure. So there's going to be a little bit of additional buffer for having someone to maintain the infrastructure, also providing safeguard, things like that could also contribute to overall TCO. The bottom line is there's no simple answer, but I think this is a bit of comparing apples to oranges, if you will. But again, the important thing is, from a Dataiku's perspective, we don't really. We have native services that we integrate with, so you can actually test out those scenarios across different third-party services. And if you do have a flexibility to add your GPUs, maybe this could be a test cases where you can actually try out what works best for your organization.
Okay, so we have about 1 minute left, so we're going to speed run a couple of these questions. I did want to speak on, does Dataiku connect to AWS Bedrock knowledge bases? So coming very soon, Dataiku will be able to connect to AWS Bedrock in terms of Elasticsearch to use for your RAG pipelines and whatnot. So definitely look out for that. Also, I did want to comment on something that was left in LinkedIn. I don't understand how caching works. Do you have an example where a query result might be reused? I can take this as well. So let's say we have some sort of application that we set up for end users where they're often asking similar questions, maybe in a different sort of prompting style. Like, let's say, summarize this customer story or summarize XYZ. we're essentially going to cache the results and then send that back to a user that has asked that question multiple times, or another user who might have asked a similar question. So that's a way that caching can really be effective. And we do have 5 seconds, so we want to thank you all for joining us for this webinar, and we'll see you. So thank you guys so much.